Okay, so I'm just taking a look at Chapter 16, Quiz A. If you can just take a minute and read these two sentences along with me. A biology professor responds to some student questions by email. The probability model below describes the number of emails that the professor may receive from students during the day. We're going to let X equal the number of emails received. And then we're going to let the probability be P of X. There we go. So how many emails should the professor expect to receive each day? Well, we know the mean number of emails, or the expected number of emails. So this is mean number of emails, or expected value, or the expected number of emails, can be given by the equation the summation of X times P of X. Okay, so let's take a look what that would look like. So here's our X, here's our P of X, and we're going to sum up those values. So it'll be 0 times 0.05 plus 1 times 0.10 plus 2 times 0.20 plus 3 times 0.25 plus 4 times 0.30 plus 5 times 0.10. And if you add up all of these numbers, you should get an expected number of emails. And your expected value is 2.95 emails per day. So that answers part A. How many emails should the professor expect to receive each day? And you've now learned a new formula for expected value, and that formula is the sum of X times the probability of X. Okay, so moving along, same exact heading, it's still question 1. The next part of question 1 is, what is the standard deviation? Again, the formula for standard deviation in this section, well, first, in order to find standard deviation, we have to be able to find the variance. And the formula for variance is as follows. So this is sigma, right? Sigma squared is called the variance, which is a measure of spread in the data. The variance of X can be equal to the sum of X minus mu squared times the probability of X. So again, we just plug and chug. So we've got 0, take away 2.95 squared times 0.05. So here's my X. My mu, I calculated in part A. My mu is 2.95. And there's the probability of X. Plus, because we have our summation right here, 1 minus 2.95 squared times 0.10. And again, I'm getting these numbers from the table. Here's my X, here's my mu, and here's my probability of X. And then 2 minus 2.95 squared times 0.20 plus 3 minus 2.95 squared times 0.25 plus 4 minus 2.95 squared times 0.30, and finally 5 minus 2.95 squared times 0.10. And again, it's a simple calculator calculation, and you should get our variance is equal to 1.74 emails per day. However, our question didn't ask for variance, it asked for standard deviation. So standard deviation is sigma. So sigma would be equal to the square root of 1.74, which is approximately 1.32 emails per day. And wrapping up question 1. If it takes the professor an average of 10 minutes to respond to each email, how much time should the professor expect to spend responding to student emails each day? Well, we know the average number of emails is 2.95 emails per day. And if on average he spends 10 minutes, we'd expect it said blah blah blah, we would expect 10 times 2.95, or 29.5 minutes a day spent reading student emails. And this is question 1, parts A, B, and C. You've learned 2 new formulas. You've learned the expected value formula, and you've also learned the variance formula. And both formulas will show up in your Chapter 16 notes on Moodle.